Good morning, boys and girls. Today we're going to talk about inverses and the derivatives of inverse functions. Both regular inverse functions and the derivatives of inverse trig functions. Okay, we're going to throw it all together in one nice, neat little package here. But before we do that, let's talk and review just what we know about inverse functions from, Algebra 2 / trig pre-calc. For inverse functions, I hope you remember that inverses are when the inputs and outputs are reversed. We had to flip the x and y to get the inverse of a function, right? If my function was like, say, y, it's not drawing, was y equals 2x minus 1, then the inverse of this function would be, we had to flop x and y, so x equals 2y minus 1, and then solve for y, x plus 1 equals 2y, or y equals x plus 1 over 2 would be the inverse of this function. Okay, so 1, hopefully remember to find inverse like that. Quick example there, real easy. 2, I'm going to skip to the bottom. Hopefully remember the notation we use for inverse. If you remember, like just a little -1 stood for the inverse of y, or like if we had, function notation, f inverse of x. Looks like that, but that little -1 stood for the inverse, and that's the notation we used. And then the last little fact I hope we remember about inverses is the fact that the graphs are symmetric over the line y equals x. Okay, so if we go and we look at this example here of the y equals 2x minus 1, I'm going to pull this up on our calculator. All right, so I've entered the two equations on our calculator here, and if I hit graph, we should see both graphs. There's the 2x minus 1 and the 1/2 x plus 1/2 if you put that in slope-intercept form. And hopefully you can kind of see that. I don't know if I can draw on this here. But if I were to draw on this, nope, it's not letting me draw. But if I were to draw on the line, the y equals x here, hopefully you see that those two are symmetric about that. And if you folded that line over the line y equals x, those graphs would hit each other. I think we kind of can see that here. All right, but these are all some facts about inverses that we are going to find useful here in just a few seconds. Okay, so here's our problem here. Now, given f of x equals the square root of x plus x squared plus 1, and that g of x equals the inverse of f, we want to find the slope of the curve, or I guess you could say the derivative, right, of g of x at the point 3, 1. Now, your first intuition might be, well, hey, let me just go find the inverse of f, right? Let me flop x's and y's and get y by itself, and then I can just take the derivative. And that is true, however, in this function here, if you switch x's and y's, good luck trying to get y by itself. That is going to be a very difficult task if it's possible at all. All right. So that's not what we want to do, but I do like the idea. All right. So the next thing we're going to do now is we're going to use some of that information we talked about inverses to actually find this derivative or this slope. All right. So here's kind of what we're going to want to think about. Let's graph it first. All right. So again, we're going to use the calculator to help us graph this. So I typed in y equals root x plus x squared plus 1. And if I graph it, we can see that the graph of this looks something kind of like that. All right. So I'm going to sketch this graph over here now, and then we'll play around with this idea. All right. So again, here's what the graph of f looks like. We said, right, with using the calculator. All right. So then to find the graph of g, the inverse of f, we're going to use our bit of knowledge that says that, hey, the inverse is going to be symmetric with the line y equals x. All right, so if I go and graph the inverse now, if I just like reflected that over, hey, that might look something kind of like that right there. And again, I'm just doing a rough sketch, but if you fold across that line, you can see how those might match up with each other. All right. Now, again, so here's what we are trying to find. We are trying to find the slope of the function at the point 3, 1. Okay, we'll say like right there. I want to find the slope of the function, or the slope of that tangent line. All right, and again, what we're saying is we have a hard time getting the slope of this right here. So we said, hey, well, let's work with something that we do know something about. Let's try to play with the slope at the same related point on the inverse. And that would be the point, again, if you flip x and y, that would be at the point 1, 3. Okay? That's the point 1, 3. This is the point 3, 1. Because again, for the inverses, you flop your x and y, and you're really flipping every x and y on every point. All right. So if I could find this slope maybe instead, I don't know if I like that. If I can find that slope instead, though, maybe this will help us find the slope that we are really looking for. Okay? So if we're looking at just graphically, if we're looking at these graphs, you know, maybe we can see a relation between these two slopes. All right? And here's the relationship that, you know, if you don't see it, here's the relation that you're going to find, that you're going to want to find, is that the slope of the inverse is the reciprocal slope of the original function. The slope of the inverse is the reciprocal slope of the original function. Now, this is literally what I think about every time I do one of these problems. I'm going to give you a formula, but I honestly think about this every single time. So now, if I go find the slope f prime of 1 here, the slope of the inverse will be the reciprocal slope. All right, so going back and using the calculator to help us speed things along a little bit, I took the derivative, and then again, at 1, because again, we had to flip our point here, right? We're at the point 1, 3 now. And so I got the slope, f prime of 1, is 5 halves, 2.5 or 5 halves. So that means then that the slope of g prime of x, or the slope of the inverse, try to do that, maybe like that, is the reciprocal, or 2/5. And if we look at the picture here, I mean, that looks like more or less what we have drawn, right? The slope of this looks like it'd be 2.5, and the slope of this one is 2/5. They're both positive slopes. We didn't change the sign. We are just flipping them, okay? So that's how we find the derivative of an inverse. All right, so here's that formula I was talking about. If g of x is the inverse of f, then g prime of x is 1 over f prime of g of x. It is 1 over the derivative of f at the y coordinate, right? We used the y coordinate that it was at the point 3, 1, so we found f prime of 1. Okay? That's the formula. If you want to memorize that formula and use it, you can. Or again, I literally think through a graph like we just did every single time I do one of these types of problems. Okay, so here's another example of this type of problem. I'm giving you a table with a bunch of values here, and we're asked to find f inverse prime of 5, the derivative of the inverse of f at 5. Okay? And so now again, what I got to think when I do this type of problem is, again, because inverse are switched x and y, this is normally your x value, the input. Because things have been switched, this is now my y, or my output. So I need to find the input that is associated with that output. So in this case, if I look at f, the output that's associated with it, we're doing this really at the point like, hey, 1, 5 on f, or the point 5, 1 on f inverse, all right? So I got to make this connection first. So I'm really looking here, because 5 is the output, I really want to find f prime of 1. I want to find the derivative at 1, okay? And so f prime of 1, if I look at my table, is 3 halves. And then what I have to remember is that the derivative of the inverse is the reciprocal of the derivative of the original function. So now all I'm going to go and do and flip this, and that would be the derivative of the inverse at 5, 2/3. All right? Easy peasy lemon squeezy. All right, one more time here real quickly. But if you're going to do this, again, if you need to stop, rewind, watch these over again. All right? But if I want to find the inverse, the derivative of the inverse at 2. 2 is my output, so I'm looking here. That means I really want to go find f prime of negative 1. Well, hey, f prime of negative 1 is 1/2. And so I know the derivative of the inverse is the reciprocal. So 2 would be the derivative of the inverse. All right, that's how we're going to do these ones. All right, here are the derivatives of our inverse trig functions. Sine inverse, also known as arcsine, or tan inverse, also known as arctan. The use of these written both ways, I would say. But here are the derivatives of these. And unfortunately, again, I'm going to tell you, you just kind of have to have these memorized. Kind of like you have to memorize the derivatives of our sine, cosine, and tangent, functions. But similarly, if you look at these, you can see that if you do get them memorized, just like with our other ones, that the co-functions are the negative version, right? So the derivative of sine inverse is 1 over root 1 minus x squared. And cosine inverse derivative of that is negative 1 over root 1 minus x squared. And so on and so forth. Derivative of tangent is 1 over 1 plus x squared. And the derivative of cotangent inverse is negative 1 over 1 plus x squared. And I'm going to say that, again, mainly you're going to see this stuff on multiple choice. And just notice all these perfect squares. That is something I frequently use to help me when I first start out with these to help recognize the right answer. If you see a bunch of perfect squares, I thought that helped me to help zero in on the answer. But we want to have these ideally down and memorized. I am going to give you, there'll be a following video here real fast on making a flippy foldable. That is super handy, and you probably are going to want to make that to refer back to for these things. It does help out quite a bit. Okay, but ideally we're going to have these derivatives memorized because you can't use the flippy foldable on the AP exam. Oh, one last thing with these things here too. I have these all written in terms of x. So 1 over root 1 minus x squared, for the derivative of arc sine. However, again, chain rule always applies, right? So if this was a function inside of here, this might be 1 over the square root of 1 minus u squared times u prime. All right? So don't forget about chain rule since we do, or potentially do, have an inside of a function here. All right, so a couple just quick examples of the derivatives of trig functions here. I want to take the derivative of arc sine ln x, or sine inverse ln x, and just for helpful handedness, I put the formula for that over here. All right, so if I took the derivative of this, f prime of x, it's going to be 1 over the square root of 1 minus the x squared, or the u squared. So 1 minus ln of x squared. Now again, if we have an inside, I then need to multiply it by u prime. So the derivative of ln is 1 over x. And so this derivative would be 1 over x root 1 minus ln of x squared. And that's how we take the derivative. Once you have the formulas memorized, to take the derivative is not bad. It's the memorizing that is a little tricky in the first place. Okay? And again, if you use your flippy foldable, that will help you get these down in the beginning. Okay, I will say too, on the AP exam, you're mainly going to see arc sine, arc tan, and arc secant, or tan inverse, secant inverse, and sine inverse. Those are the main ones. You see the ones on the left-hand side of the column. So if you are struggling with this a little bit, focus on those three. But if you get those three, the other three are just the negative version. Okay. But here's the next one. Again, I have the formula down for us to kind of use and help us here a little bit. I want to take the derivative of secant inverse of root x. So the derivative of this is 1 over the absolute value of u times the square root of u squared minus 1 chain rule times u prime. All right? And now we just need to simplify this. All right, so f prime of x would be 1 over, the square root of x is always positive, so I can drop the absolute value in this case, I guess. And then times the square root of x squared is just x minus 1 times 1 over 2 root x. All right, and so now if I multiply these together, 1 over 2, root x times root x again is just x, root x minus 1. So that would be the derivative of this function here. All right. I hope this makes good sense to you, boys and girls. If you got questions, again, always come find me. Okay, I'm here for you. Take care, and see you next time.